Hello everyone, welcome to Code with Raj. So today we will be moving on with our top interview 150 series. The today's question is majority element. So let us come on to the question and read the problem statement. Given an array nums of size n, return the majority element. The majority element is always that appears more than n by 2 times. You may assume that the majority element always exists in the array. So in the question it is given that we need to find the element which appears more than n by 2 times in the array. So if n is equals to 5, so 5 by 2 is 2. So the element should appear at least 3 times to be considered as majority element. Okay, so let us try to solve this question. So let us take the second test case. Nums is equals to 2, 2, 1, 1, 1 and 2, 2. So what is the most basic approach you can think in this question? Like we could simply make an hash map and iterate over full nums and store count of each elements. So we can have, let's take a weird test case, like we can add 3 3 or something more, 4 5 6. So instead what we will do is, for int I is to nums, we would just do mp of I plus plus. We can have a map mp, and at last we will check in map. For auto it is to map, if it dot second is greater than n by 2, then we would return it dot second. Like from here we can see that if we return this value, we are getting our answer. But the problem with this approach is we are taking big of n time complexity, but here we are taking this extra space of this map, which is around roughly big of n. So like we need to optimize this space, because in the question, the most optimal way to solve, because if this question comes in an interview, the interview will ask you to optimize it more. And so what could be our optimization, moving from big of n space complexity or big of one space complexity? But so how to approach this question now if we need to solve this in big of one space complexity? So let us try to reorder our approach and think in a better way. Let us again take the same test case. So one of the unique things that is given in this question is that the element appear more than n by 2 times. So you know that half of the array is filled with a particular element. Now your task is to find that particular element. So like we can iterate over this array step by step, like first here, 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 here. For example, let's break this array till here only. Then uh, if array only considered of this, then you can say that 2 is the majority element because it is appearing twice. Now let us consider till here. When we consider till here, you can still say 2 is the majority element because it is appearing twice. And now considering here, now moving on further. Okay, so in this case we didn't got any majority element. So but in the question it is given that majority element will always exist in the array. So like the approach to this question would be, we can think something like 2 2 1 1 1 2 2. So we can think something like majority, the element that is our answer, to be a person which appears the maximum number of time, and rest of the elements are trying to cancel it or beat it. So if we are finding out that particular person, we will do our count plus plus. If we found something else, we will do count minus minus. And if our count went 0, we would update our, like we will have a pointer element which will store the current element on which the counter is going on. And if the count goes 0, we will change our element to the nums of I where the count goes 0, and we will put count equals to 1 because we set our new element now. So let's do a dry run on this case. 2 2 1 1 1 2 2. So we found that our first element is 2, so our le equals to 2 and count equals to 1. Now we move on here, our count increases to 2. Now we move on here and we found that the element is not equal to 2, so count decreases to 1. And then we move here and we found that the element is not equal to, our count increases, becomes 0. So now when our count becomes 0, we change our element to 1 and we move on to the next pointer. Oh, sorry, we continue iterating over the array and found the element is 1, so we would update our count to be 1. And next, we found our element to be 2, but since the current element is 1, it is not equal to 2, we would reduce it to 0. And when the count reaches 0, we would shift it to 2. So element again becomes 2, and at next step our count becomes 1. So at last we got our element to be 2. So you can see, like, this approach is modeled in such a way that each time you can cancel the element which is appearing less times. So wherever in the array this 2 will be appearing at most n by 2 times, so our count will increase in such a way that at last it doesn't become 0 and the element 2 is remaining in the LE pointer. So I think when I code it, the approach would be much clearer to you. So let us go on to the code editor and code it once. Yeah. Okay. So first int n is equals to nums dot size, and we will keep. So at the starting, our vector would be pointing to the first element. So int le would be, let us write element is equals to nums dot front, basically nums of 0, and next value would be count. For int I is equals to 0, I less than n, I plus plus. If nums of I equals to element, we would just do count plus plus. Else we would do count minus minus. And if count becomes 0, we would update our element equals to nums of I. And since we updated our element currently, so we will make sure that our count is also updated, and we will make our count equals to 1. And at last we would just return the value of count, because count will store we would just return element, because element will store the particular element which is appearing more than n by 2 times in the array. So this is the way this question is approach is working. So let us now run the code once to see that it is passing on sample test cases or not. Yeah, I need to return element. So yes, you can see that it got accepted on test cases. Now let us submit the solution. And the solution got accepted. Okay, so let us talk about the time complexity and space complexity. Since we are doing the solution in one pass only, so our time complexity will be big of n, yeah, and our space complexity will be big of 1, because we are only using two variables, element and count, which are not dependent on the size of the array. So big of 1 space complexity. So this is the most optimal solution to this question. I hope you enjoyed the video. Please make sure to press the like and subscribe button, and in the comments I would love to hear your feedbacks and anything else you want me to do in your videos. The code links would be updated soon in the description box. Thank you so much for watching. Bye.